morning. This is a follow-up to a previous video I did on using a Dell power supply as a bench power supply and how to modify it and connect it up. I've since that I've designed and had created some PCB boards from JLC PCB. They were for a Dell 2850 power supply. This will not fit a Dell 2950 power supply, though I have designed one that will. I'm probably not going to actually make it because I don't have a Dell 29, well, I have one Dell 2950 power supply, but I've already modified it. And I don't really want to go through the hassle of ordering parts. The connector, even though it's not expensive, it's $8.50. The boards are like $4 or $5 for 5 of them. Maybe, actually I think it was about $19 because I used heavier copper plating or traces. I did try this on a 2850 power supply, which I have since parted out. It did work, but I couldn't get the power supply to work consistently. When I first hooked it up, nothing happened when I turned it on other than the fan came on and there was a brief flash from the LED. And I did some research and Googling and couldn't find any reason exactly why, other than the yellow light on the back came out, or came on, and that indicates a fault in the DC output. I thought maybe it was somehow shorted, or it didn't like this. Took that out of the circuit, didn't matter. Turned it off and went off and did something for about an hour. When I came back and turned it came on and was working just fine. So I resoldered this. I turned it off, resoldered that, and it came on and it was working fine, and then I turned it off and turned it on again and I could not get it to come back on again. It wouldn't even flash the light. So I think whatever circuitry controlled the DC output, something happened to it. Unfortunately, the power supply was extremely old and I'm not even sure where I got it from, and I do not even know if it really worked to begin with. Let's go over how this is set up. This is on, I believe it's 2-ounce copper plating, or whatever they call this. I have vias to connect the two sides. And then you can see that each of these 3 connections are joined together here. And then there's a screw that goes through it, so you can actually put some kind of large wire on it. The LED is just connected across here with the resistor to drop the voltage to 2.8 volts. We have the temperature sensor like in the old one. It's meant to function the same way. It puts the power supply in low speed mode until this gets hot, and then it turns it on high, and this is just the on-off switch. Relatively simple. Anyways, at some point I have a couple of 2850 power supplies coming. Since I got the parts to make 2 of these, I ordered 2 2850 power supplies off of eBay. Hopefully one of them works, and maybe there'll be either a second part to this video or a second video. Thanks for watching. Okay, so the replacement power supplies came, and it was indeed my old power supply that had a problem. These work just fine, and I have completed putting this together. It's got all the screws in it, and I've attached a temperature thermal switch, a normally closed, and I think this one's like 104 degrees Fahrenheit. When it's fully hooked up, it would actually go on this side in front of the inlet. So let's hook this up to power, and we'll switch it on. And you see that the LED lights up, and this one is set, I opened it up and I set it for 12 volts. It was a little off. This one was actually came set to 12.2, and this one was like 12.1. And so I've changed this one to be exactly 12 and this one to be exactly 12.5. So there you go, 12 volts. The original, when I originally did this, it was a long time ago. It's been probably almost 2 years since I originally did the drawing before I actually ordered it, and I never actually paid much attention to how big this screw hole is. So it only holds a number 440, a 4-40 screw. Although I have modified the circuit board to be a 7mm, so it could handle up to a 1/4 inch bolt. Okay, before we go, I'm going to solder one together real quick-ish, sort of. This is a pretty standard on-off toggle switch. You just put it in exactly the way it's shown on the printed circuit. Hopefully my cat doesn't interrupt us. Yeah, we'll do it this way first. Now on these connectors here, not everything needs to be soldered. If you ever wanted to take this apart for some odd reason, you'd have to desolder all this, and the other ones don't actually go to anything. So the only ones that need to be soldered are this one this one, this one, and I think that's it. Let's see. Oh yeah, and this one. Then the LED, which is keyed, sort of. And the resistor in this case, because this puts out 12 to 12.5 volts, I chose a 470 ohm resistor. I have a calculator, a spreadsheet. I feed it a voltage and a wanted voltage and a amperage, and it tells me what resistance I have. It kind of does it in a matrix, so I can choose the next closest resistor that'll work. The 470 would work for rather a wide range of voltages. It just would be brighter or dimmer. Apply power, and there you go. The fan is louder because this doesn't have the temperature, the thermal switch installed. So there you go. Thanks for watching.